This lesson shows how to solve one-step inequalities with addition or subtraction. An inequality is a mathematical sentence that compares two expressions. The values of the variable that make the inequality true are the solutions. In this example, the sentence asks, what number plus 5 is greater than 8? Since 3 plus 5 is equal to 8, you can see that any number greater than 3 would be a solution. For example, for x equal 4, you would have 4 plus 5 is greater than 8, which is 9 greater than 8, which is a true statement. So the solution to the inequality is x greater than 3, or any number greater than 3. So when like an equation, the solution to an inequality is a set of numbers which you can graph. Solving an inequality is very much the same as solving an equation. Use inverse operations which undo each other. For example, to solve an inequality that has addition, use subtraction. In this example, subtract 5 from both sides. On the left, 5 minus 5 is equal to 0, and you have x plus 0, which is just x. On the right, 8 minus 5 equals 3, and the solution is x greater than 3. This works because of the property of inequality that says an inequality remains true when you add or subtract the same number on each side. Notice that the inequality 10 greater than 8 is a true statement. If you subtract 3 from each side, you get 7 is greater than 5, which is still true. For this example, 6 is being added to x, so use the inverse operation and subtract x from both sides of the inequality. On the left, 6 minus 6 equals 0, and you have x plus 0, which is just x. On the right, 4 minus 6 equals negative 2, and the solution is x less than negative 2. To graph the solution set, draw an open dot at x equals negative 2 and an arrow to the left. Remember to always check the solution, write the inequality again, and substitute any convenient value in the solution set. That is, any value less than negative 2, like negative 3. Then, negative 3 plus 6 equals 3, and the solution checks. For this example, 7 is being subtracted from x, so use the inverse operation and add 7 to both sides of the inequality. On the left, negative 7 plus 7 equals 0. You have x minus 0, which is just x. On the right, negative 3 plus 7 equals 4, and the solution is x greater than or equal to 4. To graph the solution set, draw a solid dot at x equals 4 and an arrow to the right. Remember to always check the solution. For this example, 5 is subtracted from x, so use the inverse operation and add 5 to both sides of the inequality. On the right, negative 5 plus 5 equals 0, and you have x minus 0, which is just x. On the left, negative 6 plus 5 equals negative 1, and the solution is negative 1 less than or equal to x. Notice that this is backwards. For an inequality to make sense, the variable needs to be on the left. So flip it around, and you have x greater than or equal to -1. To graph the solution set, draw a solid dot at x equal -1 and an arrow to the right. Notice that x equals 0 is an easy choice for checking the solution. This lesson showed how to solve one-step inequalities with addition or subtraction. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.